Welcome back. In this video we are going to talk about errors. Errors are inevitable, but in this video we also learn ways to handle them in our code. Alright, and there are two types of errors in Python that we are going to talk about. We are going to talk about syntax errors and then exceptions. Now, syntax errors are normally caused by the programmer. Okay, if you try to do something that is not, or that does not syntactically agree with Python syntax, then we will get that error. So let's look at an example. If 5 is greater than 2 and we are saying print, let's say true, and then if we run this code now, we are getting syntax error, expected a column. What we should know is that syntax errors are quite easy to fix than exceptions. If you use any code editor or IDE that supports syntax highlighting, the IDE or the code editor will many a time give you suggestions and clues to fix syntax error, as PyCharm is giving us here. You can see this red underline, and if you hover over it, we are getting expected a column. So we can just fix this by putting a column here, and then if we run this, we are getting true. Our code runs successfully. All right, another type of syntax error is called indentation error. So if you try to do something like this and then we print, let's say A, and if we run this code right now, we are getting indentation error, unexpected indent. But what we should know is that indentation errors are subclasses of syntax errors. So in Python, you don't have to bring unnecessary indentation. Now, for exceptions, your code might look syntactically correct, but when you run it, you will get errors. So many a time, exceptions occurs during the execution of the code. All right, so let's look at some exceptions that we can get. So let's say if you try to print A right now, we are getting name error. Name A is not defined. This is a type of error or exception that we normally face when we don't define a variable and then we try to use it in our code. All right, but if you write a program and then the user try to input something and the user get these errors, it will be quite annoying. So we have to find ways to deal with these errors or throw something quite friendly to the user. Okay, and also if you try to do, let's say, 1 divided by 0, we are getting 0 division error, division by 0. All right, so these are some of the exceptions that we normally face. But let's look at the ways that we can handle errors. All right, called error handling. We use try except statement to handle our errors. It can be used anywhere in your code. So for this, we will say try, then we bring our column, and then we put the code that we want the interpreter to try here. You have to make sure that it's indented, like you are using the if statement. Okay, so here we are going to take a number from the user, an integer of course, and then we will try to divide 10 by that number. Okay, so here you say print 10 divided by num. So you put the code that you will normally try to use it independently in the try clause. Okay, then after that you use the except clause or statement to catch any errors that will be raised. Okay, so here we can say print something went wrong. So what we have done here means that the interpreter should try this code, and then if no error occurs, we are good to go. This except will not run, but as soon as something goes wrong here, okay, this statement will be printed. So try this except that an error occurs, then you print this. So if we run this right now and then we are getting enter a number, we enter 1, we are seeing here that the code runs successfully because we entered an integer. But what about if we run this code again and then we enter, let's say, FG? We are getting something went wrong because we didn't enter an integer. So normally, if not because of this try except statement that we have used here, an error will be thrown. Okay, we will get value error. If we copy this code here and then we put it here, let's comment this one out and let's see the error that we will get if we input the same thing here. We are getting value error, invalid literal for int with base 10 FG. So if our variable here is expecting an integer but we input a string, this is the type of error that we are getting. But we can see that when we place this code in the try and accept, this ugly error didn't occur, but the friendly thing that we put under the accept clause was printed. Alright, so that is how we use the try and accept to handle errors in our code. So this one that we have done here will catch any exception that will be raised when the try statement try to be executed. So if we hover over this, we are getting two broad exception clause. Alright, but since we know the specific error that we might be facing in our code, we can put the name of that error here after the except, and then when that error is encountered during execution, we print this statement. But before that, let's run this code again and then let me enter 0. If we hit enter, we are getting something went wrong. Okay, for this we are expecting that the 0 division error will be raised because in math we can't divide a number by 0. But because of the try and accept that we have used here, it is catching all types of errors. So for us to be more specific, we can bring, let's say, accept value error, then here we can enter please enter a number. So if you run this code again and the user enters, let's say, 2, we are getting 5.0. But if the user enter, let's say, string hj and we hit enter right now, we are getting please enter a number. So obviously the value error was raised. But since we are specific here, if we encounter any other error other than the value error, so let's put 0 here, and then if we hit enter, you see we are getting the 0 division error, division by 0. So we can copy this error also, since we know that our code can encounter the 0 division error, and then we can chain our accept clauses. Okay, so here too we can put accept 0 division error here, and then we can say print enter a number different from 0. Okay, so if we run this code again and then we enter 5, we are getting 2.0. If we enter 0, we are getting enter a number different from 0. And then if we run it again and then we hit anything, we are getting please enter a number. So for this type of code that we have written here, we are catching all the possible expected errors that we can get. Also, we can put errors as an alias. So here for accept value error, we can say as, let's say, e or err, anything that you want. It's just a variable. So here we can actually print the error. All right, so if we run this and then we hit FG, we are getting the error message from Python. All right, so we have your invalid literal for int with base 10. So we can actually write something here. If it's a value error, then we can say, let's say, please enter a number. Then we print this. All right, So if we put full stop here and then we run this again, we are getting please enter a number. Then we add the message from the interpreter. So we can put our error as an alias like this. So if we use it this way, then we can pass in multiple errors as a tuple. All right. So if you put this one in bracket like this, then value error, we can also put in here the zero division error as error, right? Then we should clear this one since it's not only the value error that we are expecting. So if we print this and then we enter 0, we are getting division by 0. All right, so we can divide by 0. That is the message that the Python interpreter prints when you try to divide a number by 0. So let's run this again and then we enter a string. We are getting invalid literal for int with base 10. So these are all different ways that we can handle errors. You have to use the one that works for you or that is most efficient for you. Also, we can use the keyword called exception here. All right, and this will catch all the errors too. Okay, so if we run this and then we hit 0, we are getting division by 0. This is broad. This is not like the one that we did previously. This catches any other errors. So let's put something here, something that we have not defined, let's say a variable. Okay, and then let's run this code. If we run this and then let's enter any number, let's say 5, you see we are getting 2.0. This line ran correctly, but the exception catch this error, that is name A is not defined. So this exception catches all errors in its directory. All right, but as a programmer, when you write a code, it is better to know the type of errors that you might be encountering, that is the type of exceptions that you might face in your code. All right, so that you try to chain them as we did, using the chained except statement to catch all the possible errors that you will encounter, your code might encounter as users try to interact with your program. So that is a good way. If you generalize your exception code or statement like this, then you can't suggest or give clues to your user what he or she should do. You can't tell your user to do the right thing. All right, because if you do this, we are just only printing the name of the error and not actually try to tell the user anything. But when you look at the ones that we did previously, when you encounter zero division, we tell the user that please enter a number different from what? 0. And then if the person doesn't enter an integer or a number, we tell the user that please enter a number. So the try except statement have another clause or have another option called the else statement. All right, if you use the else here, this else statement will only run if there are no exceptions encountered. All right, that is if the try clause, the code in the try clause runs successfully. So if the code doesn't, we don't encounter any exception, then the else statement will be executed. So here, if we hit this invalid literal, we can see that the else statement wasn't executed. But if we hit a number, let's say 5, we can see that the else statement was executed. And since we didn't get any exception here, now we entered 5. 5 plus 1 is 6. So this can become useful when we are building complex projects. And then lastly, we have another option in the try and accept statement called finally. The finally runs no matter what, whether you get an exception or you don't get an exception, the finally statement will be run. So if we run this code and then let's say we hit something, we get an error, still the finally code will be say we are done. If we enter a valid number, let's say 20, still we are getting we are done. So the finally always print regardless whether exceptions were raised or not. So this is how we can handle errors in our code, but there are more exceptions that we might face. So if you try to Google around for built-in exceptions, let's see, Python built-in exceptions, and then if you run this, let's see what we are getting. As you can see, we have a lot of them here. So we have the exception itself that we use, all built-in non-system existing exceptions. Then we have arithmetic error. So you can read around this. You don't have to memorize these. You will get them as we move on, and then we will try to handle them as we have shown. This error, end of file error, EOF, raised when input function hits an end of file condition. Then we have import error. You can just Google around and then read about them. Index error raised when a sequence subscript is out of range. So if you remember when we were learning list indexing, string indexing, and slicing, we get the index error. And then key error when we are using a dictionary or any of the mapping data types. Name error, we just encountered it. So these are examples of the exceptions and errors that we might face. So bye bye for now. In the next video we are going to talk about loops. Bye bye.